So our next topic is solid state physics. So here the basic discussion starts with classification of materials based on their structure. Okay. So the materials are classified into crystalline and amorphous materials. And crystalline materials have well-defined structure. Amorphous, no definite structure. And crystalline materials have, they exhibit anisotropy. That means they exhibit different properties in different directions. So amorphous materials are isotropic. Isotropic means they exhibit same property in all directions. Suppose here you have piezoelectric crystals. So if you apply pressure in one direction, you will get electric field in another direction. And if you apply electric field in the other direction, you get vibrations in a particular direction. So whereas amorphous materials exhibit same property in all directions. So crystals have sharp melting and boiling points. Because they have specific bonds and specific bond lengths, all bonds will break at the same time. At the same temperature. So here the bond lengths may not be fixed, bond strengths may not be fixed. These are the basic differences between crystalline and amorphous materials. Bond lengths, yes, bond lengths remain same. So they'll have sharp melting and boiling points.
Bond
That means
ఒక రెండు బాండ్స్ మధ్య గ్యాప్ అసలు బాండ్ లెంగ్స్ అంటే
రెండు ఆటమ్స్ మధ్య ఉన్నటువంటి separation between two atoms. that is the reason why they have sharp melting and boiling points. So bond dissociation energy will remain same. So suppose that one bond breaks at 90 degrees centigrade, all bonds will break at 90 degrees centigrade. So entire material melts at 90. So here some bonds may break at 90, some bonds may break at 85, some bonds may break at 95, 100. So the entire metal may not melt at a fixed temperature. That is the basic difference between crystalline and amorphous materials. So now we are going to study of crystals. So here the basic observation is the materials with same structure are exhibiting same properties. With similar structures exhibit similar properties. So it is not what is there that matters, where do those atoms sit is a matter of interest. So it is not the type of the atom, it is the location of the atom that matters for crystalline materials. So we divide the entire crystal into two parts. So lattice gives you the location of atoms. And basis gives you the name of the atoms. Okay. So lattice gives you where the atoms are sitting, and basis gives you what are the atoms. So it is more important to study about lattice than basis for crystalline materials, because the structure decides majority of the physical properties. So we study the properties of those lattices. So lattice is a periodic repetitive structure. సో ఆటమ్స్ని రిపీటెడ్గా అరేంజ్ చేస్తూ పోతాం. So in that, what are the possible structures? So I'm considering a two-dimensional space, and I want to see how this, what are the different possible combinations or different possible structures in two dimensions. So I'm taking a set of points. This is one possibility. Another possibility, maybe one atom is sitting in the middle. Okay. మధ్యలో చెప్ప వస్తుంది ఇప్పుడేమో స్ట్రైట్ లైన్ డాట్స్ వచ్చేస్తుంది. లేదా బేసిక్ టూ పాసిబిలిటీస్. రైట్. సో ఇప్పుడు మనకి పాసిబుల్ స్ట్రక్చర్స్ ఏంటి టూ డైమెన్షన్స్? సో యూ కెన్ కనెక్ట్ దిస్ పాయింట్స్ in any order and we get a periodic repeating structure. Suppose if I connect these points like this, I get a square lattice and the structure is repeating. I can also connect these points in the shape of rhombus and the structure repeats. The same lattice can be connected in different possible ways. So I may connect every third point. So the set of points can be connected in any direction, in any orientation. The only condition is the structure should be repeated. Okay. So now, what are the possible different structures in two dimensions? So one is a square lattice. Rectangle, rhombus, body centered rectangle. So I can connect this like a body centered rectangle. I can also connect this like a rhombus. Repeat. I connect this, structure changes. Okay, upper triangle అయితే ఒక lower triangle.
Only just a triangle upper or lower.
Same repeat అవ్వాలి. So now a body centered rectangle is basically a special case of rhombus structure, where the corner of the rhombus falls at the center of a rectangle, a bigger rectangle. So the corner may not always fall at the center. So it depends on the angle of the rhombus. So in a special case, the corner may fall at the center of a bigger rectangle. So what is so special about it? So I'm collecting all the crystals with rhombus type of structures, and I'm trying to study their melting points. Okay, and in one structure, it has very higher melting point compared to all the others. So as I've seen, depending on the structure, all the materials will exhibit similar properties. So, but here, one material out of all the rhombus structures is exhibiting a different property, very sharp, very high, or very different in nature, very high melting point or very high boiling point. So then, the reason is one of the corners of the rhombus is falling at the center of a bigger rectangle. So here, all the forces are balanced and the material is most stable compared to rest of the rhombus structures. So, how do I come to that conclusion? I mean, even if I know the angle of the rhombus, I can get a conclusion. After some mathematical calculations, all the forces are balanced. Kind of conclusion may come even if I know the angle of the rhombus. But if I represent the structure like a body-centered rectangle, it will give more visual impact, right? So that is the basic difference between, it is only a representational convenience. So this structure is called primitive cell. The cell with one atom per cell. So here each corner is shared by 4 cells, right? So each corner will have a contribution of 1/4. The total number of atoms in the cell is 1. Whereas here, the total atoms are 2. And this is called a unit cell. So unit cell depicts the symmetry information. So unit cell may have 1 atom per cell, or it may also have 2 atoms or more atoms per cell. But the main purpose of unit cell is to represent the symmetry completely. How the forces are balanced, how the atoms are arranged. All the symmetry information is clearly represented in unit cell. So it may require more than 1 atom sometimes. The main purpose of unit cell is to represent the symmetry. Whereas this primitive cell is used for all mathematical calculations. Because more the atoms, more is the complexity of mathematics. So here in primitive cell, it carries the symmetry information. Still, you get a possible conclusion only when you complete the mathematical calculation. So without calculations, you cannot get any symmetry information. So that is the basic difference between a primitive cell and a unit cell. Primitive cells are used for mathematical calculations. Unit cells are for visual representation of symmetry. So basically, body centered rectangle is a special case of rhombus. But it is also studied as a special category because of its symmetry. So one more special case in this rhombus type structures is hexagon. Hexagonal lattice where the angle, one of the angles is 120 degrees. So if we repeat this structure, we'll get hexagon. Once you fix one thing at 120, I mean, you are repeating the same structure, right?
Yes, sir.
So this is 120 and 120. What are the rest of the angles? 120 and 120. Total is 360, right? So you'll have 60 plus 60. Then every angle will be 120. Thanks, sir. I mean, if you take one angle as 120, the rest also will become 120 because you are just repeating the structure. So that is one special case of rhombus structure. And this body center rectangle is also a special case of rhombus structure. So the structures are square and rectangle.